All right, the last bit of information that we're teaching you today, and this has been a very long lesson and difficult lesson, we are aware. Thank you for hanging in there. We're talking about differentiability now, and differentiability just means that a function has a derivative at a given point. So what does it mean for a function to be differentiable at a point? A derivative is defined at that point. And that just means that the function has a defined slope at that point. So differentiability just means that you can calculate or find a derivative. So what does it mean for a function to be differentiable over an interval? So it's the same, except for now, instead of at the point, it is over an interval. So if I say that a function is differentiable across all real numbers, that means we can calculate a derivative at every point on the entire number line for that function. So let's consider a few examples. Is the absolute value function differentiable at x equals 0? So let's recall what the absolute value function looks like. And let's recall that at x equals 0, our slope from the left is negative, our slope from the right is positive. Therefore, we cannot calculate a unique slope at the origin. And the answer is no. And it's because there is that sharp corner. We also call it just a sharp point. Is the cube root of x differentiable at 0? Let's remember what this function looks like. It looks briefly increasing it looks briefly vertical right at the origin. And so the answer here is no, because the function has a vertical tangent line at the origin. This is the step function, also known as the greatest integer function. So f of x being the greatest integer function looks like this. That's supposed to be a hole right there. Let's see, there. Better to draw it exaggeratedly. Okay, and at each integer here, there is a new step. You've heard of the step function before. So at x equals 2, do you see how there is a discontinuity in the function? Therefore, we cannot calculate a slope because we can't draw a tangent line to the point. And so the answer is no, due to the discontinuity. Next question is, does the function x squared minus 5x plus 6 all divided by x minus 3, is it differentiable at 3? Well, if I factor out that numerator, I'm going to get x minus 3 times x minus 2 all over x minus 3. And these cancel to create a hole. So there's a hole at x equals 3. That is another discontinuity. You cannot graph a tangent line where there is a discontinuity because there's no point of tangency. Then the next question is the function the square root of x squared plus 0.00001 differentiable at x equals 3? And the answer is sure. This is no problem at all. Take a look at the graph if you'd like to. Put it on Desmos, put it on your TI-89, and graph it and see if it looks like it's a smooth continuous curve at 3. And it is. So here's the thing. There are no sharp points, no vertical tangent lines, and no discontinuities. And therefore, this graph is differentiable at 3. So the three conditions under which a function could fail to be differentiable are the following. Sharp points create a problem and make a function non-differentiable, and that's like the absolute value function up here. Vertical tangent lines, such as on the cube root function that I drew in B, and any kind of discontinuity, because you cannot draw a tangent line to a point that is not defined or isn't even there. So the next question is, this should say if a function is continuous, sorry for the typo, if a function is continuous at some x value, must it be differentiable there? Well, the answer is no, because of the sharp points or the vertical tangent lines. Both of these functions, the absolute value and the cube root function, are continuous everywhere, but they both have points where they are not differentiable. The next question is, if a function is differentiable, at a point, must it also be continuous there? And the answer is yes. If you were able to differentiate or find a slope, then you must have been able to draw a tangent line to that point. And if you were able to draw a tangent line, then there must have been a continuous function there. So the answer to here is yes. So these two ideas are not biconditional, meaning if it's continuous, it is not necessarily differentiable, but if it is differentiable, it is most definitely continuous.